Okay, today we're going to derive the half-angle identities for sine, cosine, and tangent. I'll do cosine first, and then I'll leave sine and just write it down, and then I'll show the tangent one. The tangent one's a little bit tricky to figure out because it's going to involve dividing sine by cosine, but you'll see. So, where do half-angles come from? Well, we've looked at the double angle identity, and let me write that down for cosine. Cosine of 2x equals cosine squared x minus sine squared x. And your homework from last night was to figure out how to rephrase this one with just cosine squareds. So I'll write the other way to the other identity for cosine of 2x using just cosine squareds. So let's write that one. Well, we replace this one with 1 minus cosine squared x, like that. And distribute this negative sign through, and we'll see negative 1 minus negative cosine squared, so it's a plus cosine squared, to cosine squared and cosine squared, which is 2 cosine squared x minus 1. So that's the identity for cosine 2x, just in terms of cosine x. Okay. So, how is this going to help us find the half-angle identity? Well, this angle is double whatever this one is, right? So that says that this is half of 2x. So let's make a substitution here to really show that and say, well, let's call 2x equal to some angle theta. And what do we replace it? So let's do a replacement here. That says that cosine of theta equals 2 cosine of, if I divide this by 2 and divide this by 2, this becomes x equals theta over 2 cosine squared of half of theta minus 1. So this is the substitution. Okay, so now we have cosine theta equals 2, cosine squared theta over 2 minus 1. And if I look, I want my answer to be in terms of the half angle. So I want to get cosine of theta over 2 by itself and see what we get. Well, all right, so let's start undoing things to this cosine. We add 1 to both sides, plus 1, plus 1. So that's I'm going to kind of reorder things around here and write this as 2 cosine squared theta over 2, put that on the left, and then 1 plus cosine of theta. Next up, divide by 2. So that gives me cosine squared theta over 2 equals 1/2 times 1 plus cosine theta. And the last step is to take the square root. So it says then that cosine of half of theta, half of x, or whatever the angle is equal to plus or minus the square root of 1/2 times 1 plus cosine theta. That's the half-angle identity for cosine. Now, you might ask this question, why is there this plus or minus? Well, when we took the square root, we get 2 possible answers, a positive answer and a negative answer. And the square root itself can only be positive, but we know cosine of half angles, we know some half angles where the cosine should be negative. And so we wouldn't get those answers if we didn't include this plus or minus. For instance, if theta over 2 was somewhere in quadrant 2 or quadrant 3, you know you should get a negative answer. So you have to decide which root to pick depending on what quadrant theta over 2 is in. If theta over 2 ends up being in quadrants 2 or 3, you should take the negative root. If it's in quadrants 1 or 4, you should take the positive root. So I'll just write that down. If theta over 2 is in Q2 or Q3, then take negative root else, oops, take the positive root. Of course, else means quadrants 1 and 4. Okay, so there's the half angle identity for cosine. Now I'm going to just write the half angle identity for sine on the board, so let me erase this. Okay, so we have the half angle identity for cosine. Cosine x over 2 equals plus or minus the square root of 1/2 1 plus cosine theta. And the sine of a, oops, sorry, let me get my numbers right. Just put x's instead of thetas, it doesn't matter. Sine of x over 2 equals plus or minus, it's very similar looking, square root of 1/2 1 minus cosine of x instead of 1 plus cosine of x. And then lastly, the tangent of x over 2. Well, I'm going to derive that one because it's actually a little bit of work to derive. It's not obvious. Well, remember the tangent of x over 2, right? Tangent of is sine over cosine. So tangent x over 2 is equal to plus or minus the square root of 1/2 1 minus cosine x over plus or minus square root of 1/2 1 plus cosine x. Okay, so step 1 is to rationalize the denominator and see what happens. So we're going to multiply this by whatever the denominator is, square root of 1/2 1 plus cosine x over square root of 1/2 1 plus cosine x, so that we get rid of the root. So I'll just throw this plus or minus sign in front. Overall, we got to figure out what's the sign, is it positive or negative. So the numerator, we have 1/2 and 1/2, so that is 1/4, or square root of 1/4, which is 1/2. 1 times 1, so this all goes under the square root. 1 times 1 is 1, negative cosine times 1, or 1 times 1 times cosine, is plus cosine x. Negative cosine times 1, negative cosine x. Negative cosine times cosine is negative cosine squared x. And so if you notice, what happens is these cancel, the middle terms, and so we just get in the square root 1 minus cosine squared. That's the numerator. And the denominator, we get rid of the root. So that's 1/2 1 plus cosine x. Okay. Now what? Well, I noticed there's 1/2 and 1/2. Those cancel. Half on top, half on bottom. So what remains? Well, there's something I can do with this one. We've practiced this already. If you see 1 minus cosine squared, you can always rewrite that as sine squared. This is the square root of sine squared x over 1 plus cosine x. And when we square root this, we just get sine. Sine x over 1 plus cosine x. Hey, this looks kind of familiar. There's another way to write this, which you've already done. You can write it as 1 minus cosine over sine. But anyway, this is our identity, sine x over 1 plus cosine x. Now, what about this plus or minus piece? Well, it turns out that I can get rid of the plus or minus because the angle, or the sine for the tangent of x over 2 is just dependent on the sine of x. So this thing right here has the plus or minus encoded in it. And I would encourage you to check some examples to try to figure out, well, what should the sine of x over 2 be? And does it match up with the sine of x? The sine of x, the SIGN, the sine of the sine should match up with the sine of tangent of x over 2. Turns out that they will match up. Okay. So that is the tangent half-angle identity. Sine x over 1 plus cosine x. And it's also equal to, you've seen it reformulated this way, 1 minus cosine x, cosine x over sine x, like that. Either way, pick your poison. They're the same. Okay, those are the half-angle identities.